So hello everybody. Today we're going to be doing a response video for an interesting geometry problem. So what I'm going to do is slightly different. I found this problem on another channel, and I'm going to be posting the link to the original video in the description down below. Okay, now I'm going to do it in a different way compared to what was already done. So let's first give a description of our problem. So we have two squares. They're not exactly squares here, they're not drawn to scale, but we have two squares with a side length of 12. Both of them have a side length 12, and one of them is rotated counterclockwise by 30 degrees compared to the other. And what we're supposed to do is we're supposed to find the surface area that's marked in red here. The surface of the area that's marked in red on this sketch. Okay, so I'm first going to erase these red lines just because it will make things a bit simpler. And then I'm going to draw some more lines. I'm going to do it in green, and they're kind of, well, going to help us solve this problem. Okay, and also this right here. Okay, so we've divided up our area into two right triangles and a rectangle. So that's going to be easier to compute a bit. Now I'm also going to put some lines, let's say in blue, just so that we get another triangle that's going to help us solve this problem. Okay, let's actually do this one in yellow. And I'm going to mark the yellow value as, let's say, x, and the blue one as y. Since this here, this side right here, it's equal to a, or 12, I'm just going to put down 12, and this side right here is also going to be 12. Why? Because they're the sides of squares with a side length of a equals 12. So let's just go ahead and compute these x and y values first. So I'm going to be using some trigonometry. So sine of 30 degrees is equal to y over 12. And from here, it follows that y is equal to 12 times the sine of 30 degrees. Since the sine of 30 degrees is 1 over 2, that must mean that the value of y is equal to 6. Okay? Now, when we look at the cosine of 30 degrees, it's going to be equal from the picture to x over 12. And from here, it follows that x is equal to 12 times the cosine of 30 degrees. The cosine of 30 degrees is equal to square root of 3 over 2. So x must be equal to 6 times the square root of 3. Okay, now that we know that, how is that going to help us? Well, first of all, we can find this area right here of this right-hand triangle, of this right triangle that's marked in yellow color. And the area of that triangle is going to be exactly x times y over 2. So I'm just going to mark that as area 1 is equal to x times y over 2. So that's going to be 6 times 6 square root of 3 over 2, which is equal to 18 square root 3. Okay, that's one part of our answer. Now I'm going to be using the similarity of the triangles to find the area of this part of this right here of this other triangle. And how am I going to do that? Well, first of all, since we know that y is equal to 6 and that the complete side length of this square is 12, this part here must also be equal to 6. Okay? And since we also know that the height of this right here part is also 6, we can find this part right here. Okay, so by setting up, and I first have to prove that these triangles are similar. To do that, I'm going to use the perpendicular, the theorem about two angles with perpendicular sides. So if this part, let's look at this angle right here and this angle right here. This side of this angle is perpendicular to this side of this angle, and this side of this angle is perpendicular to this side of this angle. Since both of these triangles are right triangles, and since both of them have one angle that's 30 degrees, the third angle must be the same as well. And excuse me. And if two triangles have all three equal angles, they must be similar. So I'm going to go ahead and set up a proportion. So this 6 over x is equal to, let's call this value here z. 6 over x is equal to z over 6. Okay, so 6 over x is equal to z over 6, and we know that x is equal to 6 times the square root of 3. So 6 over 6 times the square root of 3 is equal to z over 6. We can cancel out these 6's right here, and that leaves us with z being equal to 6 over the square root of 3. And once we rationalize both sides, and once we rationalize this expression, we'll get that this is equal to 6 times the square root of 3 over 3, which is just equal to 2 times the square root of 3. Since we already know the height of this triangle right here, and since we know the z value, we can say that that is going to be area 2. So area 2, I'm going to mark it in red because it's red right here. Area 2 is equal to 6 times z over 2. It's equal to 6 times z over 2, which is 6 times z over 2, which is the same as 6 times 2 square root of 3 over 2. So that's basically going to be equal to 6 times the square root of 3. That's another part of our answer. And for the third area, I'll use a different color this time. Let's say orange. We already know its height is 6. And this side right here, this side, if you look at the photo more closely, is going to be equal to x minus z. Okay, so the third area, area 3, is equal to 6 times x minus z, 6 times x minus z, which is equal to 6 times x is 6 times square root of 3, 6 square root of 3 minus 2 square root of 3. So, and this together gives us 4 times the square root of 3 multiplied by 6 is equal to 24 times the square root of 3. And that's the third and final part of our answer. And our complete answer is going to be that area of this complete shaded figure, that the area of this complete shaded figure, I'm now shading it in purple, is going to be equal to area 1 plus area 2 plus area 3, or the area is equal to 18 times the square root of 3 plus 6 times the square root of 3 plus 24 times the square root of 3. And the complete area, when you add all of these up, is going to be equal to 48 times the square root of 3. That is our final answer. I hope you enjoyed the video. If so, leave a thumbs up button and subscribe. I'll see you in the next one.